What the James Webb saw shouldn't exist.
3. I Atlas. It began with a calculation, a quiet line of numbers buried deep in the Harvard Astrophysics Center's nightly data feed. Professor Loeb's models suggested something unthinkable. 3 I Atlas wasn't simply shedding material, it was dissolving into chaos. Mass readings dropped so sharply that the data team initially suspected instrument failure. But recalibration confirmed the impossible. An object the size of a mountain was disintegrating, fragmenting into millions of pieces at once. According to Avi Loeb's updated model, the comet underwent a catastrophic disintegration during its solar passage, its body torn apart by forces far beyond tidal stress. He explained it simply: we see a fragmented object, its remains scattered and pulled apart by the sun's gravity. But that alone didn't explain what followed. The physics was measurable, the equations elegant, but the implications defied reason. If this were just a comet dying near the sun, the story would end there. Yet something in the data refused to stay ordinary. As the fragments spread, their collective brightness increased. Instead of fading into dust, 3 I Atlas began to glow, intensely, unnaturally, and blue. Comets are supposed to redden as they approach heat. Dust scatters shorter wavelengths, leaving longer, warmer colors to dominate, but this one turned bluer than the sun itself. Astronomers compared it to a snowball, glowing hotter than fire. This should not happen, one observer whispered during the live feed. Coronagraph arrays from lunar orbit recorded a chromatic transformation so extreme that instruments briefly overloaded. The wavelength shift indicated temperatures exceeding the sun's 5,800 Kelvin surface. That's not an error in calibration, that's a violation of physics. Energy balance calculations became absurd. For 3 I Atlas to lose mass at its observed rate, its surface area would have to span nearly 20 kilometers, 10 times larger than what Hubble had measured just weeks earlier. You can't hide 14 kilometers of rock and ice from the Hubble Space Telescope. Only one explanation fit the data: complete fragmentation. But even then, the observations didn't behave like debris. On November 9, 2025, 11 days after perihelion, 2 independent astronomers from the British Astronomical Association, Michael Butner and Frank Nebling, captured something extraordinary, not a diffuse cloud, not chaos, but order. Their images revealed columnated jets, thin, organized beams of material stretching across millions of kilometers. One anti-tail pointed directly toward the sun, defying solar wind mechanics. The main outflow extended nearly 3 million kilometers in the opposite direction, structured, patterned, almost deliberate. Cometary debris is random by nature, particles thrown outward in turbulence, but these jets moved with precision, geometry, intent. If this was the aftermath of disintegration, it was unlike any known in history. Professor Loeb recalculated. Sustaining the mass loss observed, 50 billion tons per month, would require a nucleus far larger than confirmed, or an impossible coordination among millions of fragments. Natural explanations began to fracture under their own weight, and so the controversial possibility emerged. Artificial propulsion, directional jets, geometric columns, controlled thrust, all could be explained by advanced technology operating on principles beyond human comprehension. A distributed propulsion array functioning as a coordinated system. The idea sounded like science fiction, but so did the data. If true, 3I Atlas wasn't simply breaking apart, it was changing shape, reconfiguring itself, adapting. Through late October, Hubble, SOHO, and the James Webb Telescope gathered overlapping data streams. Spectroscopic readings revealed metallic ratios inconsistent with natural cometary material, iron and nickel in proportions matching manufactured alloys. At least 7 independent observatories confirmed the same signal. Meanwhile, trajectory analysis uncovered a deeper mystery. After perihelion, 3I Atlas began accelerating against solar gravity. The measured increase, 94 kilometers per day squared, that's not a drift, that's propulsion. Forces don't appear from nowhere. Yet, every model failed to explain the motion. To scientists, it was an equation with no constants, an unsolved system. To others, it was the first mechanical heartbeat of an interstellar machine. 3 interstellar visitors in 8 years, Oumuamua in 2017, Borisov in 2019, and now 3I Atlas, each stranger than the last. Oumuamua accelerated without outgassing. Borisov behaved like a normal comet. 3I Atlas seems to merge both anomalies, organic in structure but mechanical in behavior. When compared side by side, 3I Atlas defies every physical model known. Its spectral data suggests energy generation, not reflection. Its shape, once blurred and irregular, now appears to exhibit symmetrical alignment, like panels adjusting in sequence. Some speculate it's a natural body mimicking technology. Others whisper the opposite, that it's technology disguised as nature. Telescopes across Earth align for the closest approach, December 19, 2025. Hubble will scan the debris field, Webb will measure the heat, and deep space radar will attempt to bounce a signal off the object's fragments. But time is running out. By early 2026, 3I Atlas will vanish beyond Jupiter's orbit, fading into darkness once again. When that happens, this 6-week observational window will close forever. The data collected now will be the only record humanity will ever have. Each frame captured by Hubble, each spectral line recorded by Webb, will decide what story we tell future generations. Was it a natural collapse or a technological awakening? If 3I Atlas truly reassembled after its fragmentation, if the blue light represents active energy generation, then we are witnessing the first confirmed self-regulating object from beyond the solar system, an object capable of controlling heat, geometry, and motion. A design billions of years old, or perhaps still evolving. There's an unsettling symmetry in all this. The object entered our system at the exact moment our species became capable of observing it, like a message arriving only when the receiver exists to hear it. Even now, as coronagraphs record faint pulses every few minutes, the data reveals rhythmic intervals, like a beacon sinking across electromagnetic frequencies, too regular to be noise, too structured to ignore. Scientists remain cautious, but beneath the caution, something else is growing, a quiet realization that maybe we've been looking at the sky through the wrong lens. Maybe the universe isn't silent, it's patient. And 3I Atlas may not be dying, it may be becoming. If these readings hold true, if the temperature signatures, the acceleration, the spectral geometry all align, then this isn't a comet, it's a message, one written in light and gravity. And if we fail to decode it now, we may never get another chance. The telescopes are locked on, the data streams are growing, and somewhere within those millions of fragments, Something is watching back.